Now in this particular diagram, this is meant to be a regular pentagon where all the sides are equal. So once again, using the graph on page 301 in your workbook, this is a base of 4 and all the other sides are 4, but honestly, the length of these other sides does not help me that much on this pentagon. So if I have this pentagon, what I'm going to do is I'm going to just draw a little triangle like that. And you could see if I were to do that, I could actually have 5 of those triangles if I split this entire pentagon up into triangles. And any kind of regular polygon, we're going to find that splitting it into triangles is the best way to go. And what I can do furthermore is to make a right triangle like I had on the last example. I can take one of those triangles down here. I'm going to just show you with this one and subdivide it into 2 right triangles. And the point of this is once I have a right triangle, I can use right triangle trig because I know the base of this is 2. And what I would like to know is the height of this triangle, just for the sake of, I'm just going to call this h for the height of this triangle. Now, if that's 2 and that's h, I need to be able to find h. And to be able to do this, I'm going to need to know this little angle up here. Well, to figure out this angle, we're going to have to use the fact that I know that the entire circle all the way around that pentagon is 360 degrees. And if I were to subdivide it, I would basically have 10 of these different blue triangles, because if I was to keep going, I could split each of these red triangles I've drawn into 2 right triangles. So basically, I would have 360 divided by 10. And it is not a coincidence that that is the number of sides times 2, because each of your 5 sides would have 2 right triangles I could draw on each of those sides. So I've got 10 equal right triangles I could subdivide into them, and each of them has a angle at the top of 36 degrees. Now, I can use my trig now and say what trig function relates my height of 2 to my base of my base of 2 to my height h, and the trig function I'm looking for is cosine. So as I go here, I'm going to have cosine, and then the angle I had was 36 degrees will be equal to, actually, I've picked the wrong trig function. I apologize. It looks like what I actually have is an opposite and an adjacent, which means I need a tangent. I hope some of y'all caught me before I even caught myself on that. Tangent of 36 degrees equals 2 over h. So now to solve for h, I need to multiply both sides by h. So I have h times the tangent of 36 is equal to 2. And to finish getting h by itself, I'm going to divide by tangent of 36. Now, I know some people go ahead and put tangent in your calculator and get decimals. You might even see it worked out that way on other videos you might find online. I personally like to just go ahead and get it like this because it gives me less rounding error and less decimals to type in, because now when I go to Desmos, I can do 2 divided by tan of 36 degrees, and that gives me a height of 2.75. Always remember to make sure you are in degree mode. I am this time. I checked it earlier. And check to see if that's a reasonable value. It seems like if this short side was 2, it seems reasonable that my height could be 2.75. So I'm finding my height is 2.75. And now I'm going to find the area of one of those triangles. Well, the area of one of those triangles is 1/2 times my base of 2 times my height of 2.75. That would be the area of one of those triangles. But don't forget, I don't have one of those triangles. I actually have 10 of them. So I'm going to take this 10 and multiply it by this, and that is going to give me my total area. So I'm going to need to go back to Desmos and do 10 times 1/2 times 2 times the 2.75. And once again, I can just take what I already had there, and I can multiply that. That's my 2.75. Multiply it by my 2 times my 1/2. And don't forget to multiply it by your 10 as well. The order you type these in doesn't matter because multiplication is associative. And that gives me 27.5. So that is the approximate area of this hexagon, 27.5, because that